Laura McMasters. I was Laura Fender. I had at least one person in this room was a teacher of mine when I was at Columbus School, and my dad went to Columbus School. So we've got some history in this town. And my parents are both biologists. Kenny Fender of the Fender's Blue Butterfly, so there's that connection. My mother studied earthworms, and she's had a couple of articles written about her because of the giant Oregon earthworm, the great white earthworm, which when these fields were first plowed, that's the worm that was turned under, and they were enormous. I do this because I sow, and this is about a yard, so these are a big worm. They are listed as gone, but my mother's 96 now. She says there's still some of them someplace. So when Joanne asked me to do this, what I'll do right now, I'll just point out over here, I'm going to talk about the erratic rock, and some other erratic rocks. Erratic means misfit, or misfit means erratic, so we can call them misfit rocks. They didn't fit in. Over here are native, some samples of the rocks that would have been here already, okay? Now that's confusing, I'm sorry, but we're going to start someplace else. I'm not going to give any dates or any ages or any of that stuff, but I'm going to say very quickly that before Oregon was here, just physically in any way, Idaho was here. And then Oregon was sort of scooped up off of the ocean floor and stuck onto Idaho. And then some big volcanic action happened in eastern Washington, of all the crazy places, and that flowed all the way down here and made some of our headlands that go out into the coast, and some of our places like the Eola Hills and the Amity Hills, which they consider were reversed. The flows went into valleys, everything else eroded, and now we have the bumps left. That's ancient history. What I'm going to talk about now is much more recent. There was... again, rock samples. Okay. I have here something that I'm just going to lay here. It's about the new Ice Age National Geologic Trail. And our erratic rock out here, which I love the way it says it's in Sheridan.
We are Sheridan Fire District.
There you go, see? It really is Sheridan then. So that... is going to be on this big first national trail where you would start in Missoula, Montana, I'll explain it why, and you would come along and eventually come to our erratic rock out here between McMinnville and Sheridan. When Europeans first came here, they didn't recognize that there were, in my opinion, 3 mysteries going on here. And including, if you include Washington, eastern Washington, there was another mystery. These are geologic mysteries, you could say. One is, why is our valley so flat? The whole Willamette Valley, from Portland down to Eugene, has only a drop of about 300 feet from Eugene to Portland, a 300-foot drop. I don't know, if you had come here and looked at this great, long, wide valley, people would have thought, well, that's erosion from the Cascade Mountains. Mountains build up and then they erode down and the valley gets filled with silt. So that would have been one answer that came. But the soils weren't right. The soils that are here are not from rocks that ever developed in our Cascade Mountains or our coast mountains. And that was a man named Ira Allison who described the soils in about 1935, and eventually now we have over 100 different kinds of soils in this area. But there were soils that a man named J. Harlan Bretz, and he's the hero, he said those soils were not from the Cascades. Okay, so if those soils, the soils that we live on here, examples of the soils that we live on, were not all from the Cascades, where did they come from? He was a young man, raised in the upper Midwest, didn't grow up here, but he got an interest in this. So the third mystery are these misfit rocks. And if you can take away the blackberries and take away the ivy and take away all the young trees that have come up since the Indians stopped burning the land, and we have a lot of small trees that came up, If you take all that away, then you're going to look out over the flats and you're going to see rocks. Just like, you know, somebody plopped them down in the middle of the soils. Didn't make any sense to anybody. They thought, well, volcanic, if they were poofed out of volcanoes and they rolled down the valley. That didn't make any sense. A lot of work was done, original work. Thomas Condon, how many have heard of the Condon Lecture Series? He was the father of Oregon geology, and he, in 1871, knew something was odd about these misfit or erratic rocks. But he didn't know what. There was, again, Ira Allison. He mapped all of the erratics, and I've got books here that, and you will eventually in your life see maps of all of the erratics. He went around and counted all the erratics, from things as small as, you know, a softball, to the gigantic ones that are around, and he made a map of them. And then Portland State students found a mastodon buried underneath soil, and that is named Tututuala, and is in the Tualatin City Hall. And it was radiocarbon way back. So, and then there were what they call rhythmites, where you would look out at a road cut and you'd see, it looked like some deposit of soil and then a space and a new deposit of soil, because heavier soils tend to go down, and then the lighter ones would be on the top. Those are called rhythmites. So those mysteries were there when Europeans came here, whether they're recognized or not. And H. Harlan Bretz is bright, bright young man, eventually got a job teaching high school biology in Seattle. Having grown up in the upper Midwest, he was fascinated by glacial action, and so that when he was in Seattle, he started studying the glaciers of that area. And we never had glaciers here. Portland did, I mean, just barely Portland, but we never did here in McMinnville area, never did down the Willamette Valley. Any glacial action you see would be Cascades glacial action from the early Cascades. None here. But yet, he realized from looking in the Columbia Gorge, from looking in eastern Washington at what they call the Dry Falls. Have anybody been to the Dry Falls? I haven't yet. It's dramatic. It's a place that it obviously was caused by water, but there's no water there and there's no source of water. So that's another hint or mystery. And potholes. The potholes in the scablands of eastern Washington had these geologists just fascinated. So Harlan Bretz got married. I don't know if he had any kids at that time or not, but he went walking. He had a teacher, a geology teacher. Maybe it was a science teacher. I'm not sure if I'm right on that. But he said, this mentor said, study nature, not books. And J. Harlan Bretz was very much a man on the ground. He took his new family and they literally walked eastern Oregon, taking measurements, taking depths, and that sort of thing. And he began, what we would do now, we'd fly over. But this is something that he did on the ground, and he began to say to himself, this was caused by a catastrophic amount of water, period. He knew it. He absolutely knew it. But this was heresy. Because this idea that there could have been catastrophic source of water from someplace, the geologists were not going to buy that, the guys that were older than him. He was a young man, very young man. But he began to prove what had happened, and that's what we deal with here with our beautiful big rock, the erratic rock. As the ice age was receding, it didn't just suddenly go whoop and it was gone. It receded a bit, and then the glaciers came back down, and then they went back up. Not here, but again, up in Montana, Idaho, northern Washington, northern Montana, all of Montana, I think. Well, maybe not all. And as ice melts, it produces water. The water had to go someplace, and so what they've decided and figured this out, and this is the newest book, I recommend this one. This guy is Scott Burns. He's been to McMinnville several times. He's got family that live out here in this area, and he has a great sense of humor, so this is a fun book to read. But this is an update of the book that was written several years ago called Cataclysms on the Columbia, and I went down and got it immediately, and it's good reading. So he, in this, has laid it all out, and this was 2010, I think, maybe 9, very recent. that where we are now with trying to figure out what had happened along the way with the ice sheet melting. Okay, we've all played in the mud, I hope. Everybody in here has, I'll betcha. When you're damming up a little creek, and you've got it pretty well, dammed up, and you got and depending on the speed of the water, but it's pretty well dammed up, and then something happens, and it busts through, and you lose your wonderful swimming spot, or your wading spot. With the ice dams that were formed, as the lakes would form, as the ice would melt, there were boulders, there were chunks of ice, there were mastodons, I don't know, whatever, in this stuff, and it would build up, and then eventually top the dam, and as soon as you top the dam, it's had it. It begins to erode it on the backside, and it would burst through. And that's called the Cordilleran ice sheet. As it moved out of Canada, it created, how many have been to Missoula, Montana? I went there with my sister about 2 years ago, and as we drove down, having studied this, as we drove down into Missoula, I mean, you're driving down, I went blub, 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 because you just have the feeling that you are at the bottom of a lake. This lake was, the dam was 2,000 feet high. This happened over and over and over again. The dam would create itself, it would block up, and then it would rip through, went through, and I'm going to grab one of these, pass these around. This is just a little crude one that actually, and I've written on here, it would rip through Idaho. Okay, it goes this way. This is the accumulation of water here, and this is Idaho, and this is what then happened when it ripped through. You can just pass that on through. I've also got a map here that shows topographic detail, which is kind of fun. Ripped through the Idaho Panhandle, went into eastern Washington, scoured out the soils, the Palouse soils, gave them to us. My brother, right before I left, my mother studies earthworms, and he says, "You're going to tell them about the worm, right?" The worms of the Palouse soils in eastern Washington are very, very, very closely related to the worms of the Willamette Valley. They came with the mud. They came with the soils from eastern Washington. Down the Columbia River Gorge, I remember even as a little girl thinking, wow, that was a lot of water, did that. But, water does things slowly. Erosion happens slowly. Well, they realized then it wasn't a slow erosion. This was the bursting of its dams, which happened several times, like 40 to 90 times, would then rip, including their boulders, and the mastodon and whatever else. They would come through the Columbia Gorge, but then there was a restriction. The restriction was caused by hydraulics, dam water hydraulics, but also by lava flows. And this, we're talking about a long period of time. This would happen over and over as that Caldera ice sheet was receding. So there's a time that's going on here. It would get blocked and literally squirt into the Willamette Valley. And as it came into the Willamette Valley, it was going from 60 miles an hour to 40 miles an hour or so as it ripped out down through the valley. Well, it didn't only have rocks, boulders, and such. It had ice, huge chunks of ice. And they've done, in fact, my friend Sheila Alfson is a geologist, works with Dr. Orr. He and Sheila put together a test. They went up to the erratic rock and got some of the little pieces of argillite that are laying around, put them in ice cubes to see how much ice it would take to float a chunk of rock that was the size of the erratic rock. Because when the dam bust, then the chunks of rock with the ice would come first, because that was on the top. So that's what they propose, is that those rocks came down, the ice came here, yes?
Both of my daughters, one's a geologist from Oregon State, the other one's had geology classes.
Yes.
The professors, when they take field trips up there, and they're up at the rock, they say, look down at the red barn, the iceberg was just a little bit bigger than that.
Yeah, good, that's a nice one, yeah. Yeah, so if you've been on the erratic rock, up to the Erratic Rock State Park, if you haven't, it's worth going. The only thing wrong with it is you have to look at the dump. It's a very nice view of the dump. But So each one of these included, and this is a number that's been calculated over and over, each one of these flows held 10 times the flow of all the rivers of the world. The huge, huge amount of water. And as you look at these maps, visualize, I was trying to do this with the Willamette Valley. We're about 100 miles that way and what, 40 miles, 50 miles wide, 40 miles wide? To visualize that amount of water, take that by, 10 times, 20 times, I don't know. Somebody's probably done that work to figure out the amount of water that was dammed up behind a 2,000-foot dam and then was suddenly burst loose. It would come quickly at first and then sort of subside. So it was over a period of times. So very, very slowly settling out this marvelous silt that we stole from eastern Washington. The speed increased from about Crown Point to Portland. There's quite a gradient, quite a drop. So that's where we got up to the 60-mile-an-hour, guess on how fast they were coming in when they squirted into the valley. The rest of it, and when there were no restrictions on the Columbia, it went out the Columbia River, gouging as it went, and then, now just recently, within the past maybe 20 years, they've realized that there was a big delta of soil, mud, outside of the Columbia River that is soils from Montana, Idaho, and eastern Washington. So, that's kind of prehistory. But again, if we flash back to the people who came here, the Europeans, our ancestors, rocks are kind of cool in a place as muddy as this. So those boulders were used as stepping stones, as step stones, as hearths. They blew them up and used them as gravel. Right now, if you want to see one of these misfit rocks, you can either go up to our erratic rock, or you can go on a scavenger hunt, which I put in my book. This is Kaleidoscope. And my mom, when she was about 93, she said to me, as I was writing this book, well, whatever happened to the erratic rock at Linfield College? She went to Linfield College. And I don't know. Okay, I kind of remembered something from my childhood, but it didn't have any specifics. So I had a lot of fun because, this is like, okay, my mom's old at that point. She's 90-something years old, and she has a crackerjack memory. And I knew that, better memory than most of us in this room, I think. But I wondered if she was, I had a doubt, a moment of doubt. So I went on to Linfield College. I called up all the ex-geologists, the professors, everybody I could think. Nope, don't know of any rock and no erratic rock. Well, Corinne Sturgeon, who is a botanist there, does have erratic rock, which was found up in the hills above us here. And it's on the campus. Not that one. This one, we're talking about the 1930s rock that showed up. Well, it's in here as a scavenger hunt. But I did find it. And I was going across the campus going, whoop, whoop, because I did find it. And I'm not going to tell you where it is exactly, but it has a plaque on it that says glacial erratic rock, rafted here on the floods. It's an official plaque on that rock. So go find it. Corinne's boulder is easy to find. It's right, the Linfield Library main entrance faces to the north, and this boulder is on would be the east side or the left side as you're walking in the library, and it has a very nice plaque on it with a whole lot of information about the erratic rock and about the floods and such. And it is a typical granite. Trappist Abbey. I was walking Trappist Abbey with my dog. I found a gorgeous erratic there with big crystals in it. The one at Linfield, the one I'm not going to tell you where it is, it has big crystals in it. The Chagwin Farm has a bunch of big erratics, probably, this size boulders. Farmers don't like boulders. So, if you were going to hunt out erratics now, look in the places where, the ditches, the place where you might want to have slowed down an erosion, that kind of thing. Look at the fence posts. Look where the fence posts have a couple rocks next to them. Somebody's kicked them out there to get them out of the way. You see, Evergreen bought a bunch of property out by Hopewell, and they worked the land deeper than it had been worked for a long time. There were probably 20 erratics that are absolutely discernible as an erratic because they were made of granite. And I've got these placed over here. This is a granite rock. It's also called a diorite. This one is another granite, and it's got some mica in it, so you pass that one around. We don't grow that kind of rock around here. We just don't. We grow basalt. I've separated this. This is erratic rocks, and these are native rocks. This is what we grow these here. This is the kind of stuff that you would make a road out of. This is basalt, volcanic. And I've got some samples here. And then this is a piece of volcanic from up at the erratic rock. But it's the rock that makes the bump that the erratic rock got stuck onto. This is basalt, but it's what they call soft stone. And I just thought, boy, that's an oxymoron. But the guys, quarry guys, call it soft stone because it's got a lot of crystal in it and it breaks up. So it's not good for certain things and good for others. And then the only other rock I have here as a local rock, these are from the top of the Eola Hills of Amity Hill Road. And this is sea bottom. This is ocean bottom. This is an example of what we've done here. And it's the top of the, kind of amazing. And so those are there. This, I think, is an excellent example of what one might want if one had this larger. If you were going to be making a stepstone, this is what they call a sedimentary metamorphosed sedimentary rock. This was out at Hopewell, my friend's place. We don't grow that here. And if you found a piece on your property that was this big, you would make a stepstone out of it, or a hearthstone, or something like that. So you pass those around if you want to. It's good exercise. And so let's see. This is another granite. This is another diorite. I'll leave these here if you guys want to look at it. But this is our hero. This is a piece. Now, I did not chip this off of the rock. And so I don't know what your family says about this, but I just do not see that the rock is any different than it was when I was a kid. But this is argillite, and it's a beautiful stone, actually. I'm just going to pass it out, too. And it's laying all over up at the erratic rock. Same stuff that you find, little chips that you find there. And if you guys want me to, I will take this back up there. But anyway, that's argillite. It's a sedimentary, metamorphosed sedimentary rock. And I think, if people have questions at this point, I can answer questions, or you can just wander and look at the rocks. That does it for me.
I got a question about the rocks. It's probably nothing to go do with any of the erratics, because up there you've got the erratic rock.
Yeah.
And the soils are extremely thin there.
Yes. Yeah.
And you're just going down a foot or two.
Yeah.
But then you're into all of this water-bearing rock.
Right. Yeah, that would be...
water-bearing rock, is that a native rock?
That's the native rock. Yeah, that's the native rock. That's what this, what we call soft basalt, with a lot of crystals in it. It holds a lot of water.
Well,
Yeah. Okay, that's the...
original
Yeah.
water system for our place was up there.
This one.
Is that what you're wanting?
Yes.
That's what
This
you're
is...
really
Yeah,
doing?
I'm sorry, I didn't pass this one around. But this is the soft basalt. And it is porous. I mean, it is volcanic. But it cooled slowly enough that those crystals formed, which is, and it looks entirely different. Here, this one's about the same size, and this is what we do, this is what we make our roads out of. So this is the same thing, basalt, made by a volcano, but that's a hard rock.
I think Violet had a question.
Yes.
I have a question. I was watching a program the other night, and this guy was talking about our soils
Right,
and how they're supposed to be treated.
right.
Like 50 years ago, we could eat one apple for this nutrition. Now you have to eat 7 of them to get the same nutrition that was there.
Right.
But he talked about rock dust.
Rock dust.
I haven't had a chance to Google it in.
Yeah, you got me. I'm going to Google it too.
Well, they was talking about, it's the minerals in our soil that
Yes.
are lacking. It's all these rocks that are in quartz. The ice flows, wash the rocks and scrub off that stuff. And gives us our minerals.
Right, right. Well, again, we didn't have ice. Places like in the eastern United States, where the glaciers came down and they did erode. We didn't have that here. And like I said, this soil that we got from the Palouse soils that we stole from Washington are rich in the nutrients. We all know that. We're all farmers or gardeners that, you know, if you can just break up the clay, then you've got fantastic soil. If you can't break the clay up because the particles are so tiny, it's so squished together. Our secret is mulch. It's compost. The nutrients are there in our soils. But we need to break it up. Yeah.
This one here.
Yes.
Did you break it or did it break itself?
No, that one was broken by my geologist friend.
Okay.
They break rocks.
To see what's inside.
Yeah, exactly.
Okay.
Yeah.
Okay.
And so it's a nice example of the mica. You see the little pieces of mica in there? And that isn't erratic. That one came from elsewhere. So.
Well, Laura, thank you so much, and I want people to come up and look at
Yeah,
things.
come on up.
Thank you, thank you.
My pleasure.